Have you ever considered what is the maximum value of the square root of sine x plus the square root of cosine x? Now, the answer is not 2, because there is no angle x such that both of these are simultaneously 1. However, there is a maximum, and we're going to go over that in this video. Now, whenever I see trig expressions like this, I like to square the entire expression, especially if there's like a square root somewhere here, right? So, observe that this expression is the same as this entire thing squared, and then you just take the square root back, right? We still get the same expression. Now, we're going to expand the thing inside the square root. If you expand inside the square root, you would get sine x, all right? And then plus cosine x. And then you get plus 2 times the square root of sine x times the square root of cosine x, right? We're just expanding the brackets. Now, we can actually combine the square root into one entire square root. So I'm going to use an eraser to erase that. And we can combine this entire square root, right, by the property of square roots. And now, this might look all too complicated. However, there is one formula we can use to kind of simplify this. If you know the formula sine 2x is equal to 2 sine x cosine x, this is the double angle formula, we can now divide both sides by 2 to obtain an expression for sine x times cosine x in terms of a sine expression. So we may replace this entire thing with, you guessed it, 1/2 times sine of 2x. Now, this is, I guess, a bit simplified. So how do we get the maximum value of this, right? Well, observe that our maximum value must be positive, because you can just plug in a random value for x, such as pi over 3. That will get a positive value for sine x and cosine x, and thus the entire expression is positive. So we know that the maximum value is positive, hence we use the positive root. So expecting this to be positive, we need to now consider, can we find the maximum value for sine x plus cosine x and 2 times the square root of 1/2 times sine 2x? Can we find their individual maximum values? Well, this one is very easy. Notice that if you want to maximize this entire expression, you have to maximize sine 2x itself. Well, we know that sine 2x, it's a sine, so sine 2x is smaller or equal to 1. Its maximum basically is 1. So, what value of x will achieve that? Well, one value of x that will achieve that is pi over 4, because sine of 2x in this case, if it's pi over 4, we would be doing sine of pi over 2. And sine of pi over 2, or 90 degrees, is equal to 1, achieving our maximum value. So we see that one value of x that achieves this maximum value is x equals to pi over 4. But what about this? What about this one? How do we get the maximum value of sine x plus cosine x itself? This one is actually not that hard. We can use the same trick of writing this as the square of this expression and then just taking the square root back. It's the same thing, right? Now we can again expand inside the brackets. So you get sine squared x plus cosine squared x, and then plus 2 sine x cosine x. Now, by Pythagorean identity, sine squared plus cosine squared, this over here is just 1, right? It's just 1. So basically, we have 1 plus, and now what is this? Remember, this is the double angle formula. This is sine of 2x. So let's replace this entire thing with sine of 2x. And notice that this, which is equal to this, is maximized exactly when sine 2x itself is maximized. What's the maximum value for this? It's 1, right? And x, specifically, one possible value for maximum is again pi over 4. Try it yourself. So we see that taking all this into consideration, the maximum value for this sine x plus cosine x part can also be achieved at x equals to pi over 4. And amazingly, they coincide into the same value. There's an overlap. So with this incidence, we can actually conclude that since they are both maximized at an exactly same value, right? Then, and remember, oh sorry, I should have gotten the maximum value. Okay, recall that this was equal to 1 plus sine of 2x. Okay, so this over here, we want to, it's the same as finding the maximum value of this, okay? So this maximum value, therefore, is achieved when sine 2x is maximum, i.e., this has to be 1. So the maximum value for this entire thing, which we have over here, is root 2, because it's just 1 plus 1 root 2. So the maximum value for this is, okay, I'll write it here. This is going to be smaller or equal to, this over here maximum is root 2, and this over here, well, this maximum is when sine 2x is 1. So thus, its maximum would be 2 times the square root of 1/2, right? So the square root of 1/2 is equal to 1 over root 2. And if you rationalize the denominator by multiplying top and bottom by root 2, then you would just get 2 times root 2 over 2. And now 2 and 2 cancel, so that's root 2. So the maximum value we see for this expression is also just root 2, right? Now we can add these up together. So that's 2 root 2. And we can maybe simplify a bit if you wish. You could maybe write this as, well, it depends how you want to write this, basically. We know that this over here is the square root of 8, okay? 2 root 2, if you're familiar, this is the same as the square root of 8. Now the square root of square root, I should probably write in equal signs at this point, but the square root of square root is equivalent to the 4th root. So you could write it in a much more neater way as the 4th root of 8. And this over here is the maximum value of square root of sine x plus square root of cosine x. And that is our answer. If you learned something new in this video, if you found this video interesting, then please do consider dropping a like and subscribing. Thank you very much. Bye.